It is universally accepted that the ozone layer in the stratosphere protects us from harmful UV radiations. The depletion of this ozone layer by human activities may have serious implications, and this has become a subject of much concern over the last few years. Ozone is also formed in the atmosphere through chemical reactions involving certain pollutants like SO2, NO2, aldehydes on absorption of UV radiations. The atmospheric zone is now being regarded as a potential danger to human health and crop growth. What makes ozone a destroyer as well as a protector needs to be elaborated. Ozone, the destroyer. The temperature decreases with increasing altitude in troposphere, while it increases with increasing altitude in stratosphere. This rise in temperature in stratosphere is caused by ozone layer. Ozone has two important and interrelated effects. Firstly, it absorbs UV light and thus protects all life on earth from harmful radiations. Second, by absorbing the UV radiation, the ozone layer heats the stratosphere, causing temperature inversion. The effect of this temperature inversion is very interesting. It limits the vertical mixing of pollutants, thereby causing the dispersal of pollutants over larger areas and near Earth's surface. That is why a dense cloud of pollutants usually hangs over the atmosphere in highly industrialized areas, causing several unpleasant effects. The waste spread horizontally, relatively fast, reaching all longitudes of the world in about a week and all latitudes within months. There is therefore very little that a country can do to protect the ozone layer above it. The ozone problem is thus global in scope. The ozone near the Earth's surface in the troposphere creates pollution problems. Ozone and other oxidants such as peroxyacetyl nitrate (PAN) and hydrogen peroxide are formed by light-dependent reactions between NO2 and hydrocarbons. Ozone may also be formed by NO2 under UV radiation effect. These pollutants cause photochemical smog. Increase in ozone concentration near the Earth's surface reduces crops yield significantly. It also has adverse effect on human health. Thus, while higher levels of ozone in the atmosphere protects us, it is harmful when it comes in direct contact with us and at plants at Earth's surface. In plants, it produces visible damage to leaves and thus decrease in yield and quality of plant products. Threat to ozone protector. Ozone protects us from harmful UV radiations from the sun. In spite of being in such a small proportion, it plays a major role in climatology and biology of the earth. It filters out all radiations below 3000 degrees. Thus, ozone is intimately connected with the life-sustaining process. Any depletion of ozone, therefore, have catastrophic effects on life systems on the earth. What has caused this depletion? Ozone layer by absorption of UV radiation heats the stratosphere, causing the temperature inversion. This temperature inversion limits the vertical mixing of pollutants. However, in spite of this slow vertical mixing, some pollutants enter the stratosphere and remain there for years until they react with ozone and convert it to other products. These pollutants thus deplete ozone in the stratosphere. Major pollutants responsible for this depletion are chlorofluorocarbons, nitrogen oxides, which are coming from the fertilizers, and hydrocarbons. Chlorofluorocarbons are widely used as coolants in the air conditioners and refrigerators, cleaning solvents, aerosol propellants, and in foam insulation. CFCs are also used in fire extinguishing equipment. Depletion of ozone in stratosphere causes direct as well as indirect harmful effects. Since the temperature rise in the stratosphere is due to heat absorption by ozone, the reduction in ozone would lead to temperature changes and rainfall failures on Earth. Moreover, 1% reduction in ozone increases UV radiation on Earth by 2%. A series of harmful effects are caused by an increase in the UV radiation. Cancer is the best established threat to men. When the ozone layer becomes thinner or has holes, it causes cancers, especially relating to skin like melanoma. A 10% decrease in stratospheric ozone likely to lead a 20 to 30% increase in skin cancers. The other disorders are cataracts, destruction of aquatic life and vegetation, and loss of immunity. Apart from direct effects, there are also indirect effects. Under greenhouse effect conditions, plants exposed to UV radiation showed 20 to 50% reduction in growth, reduction in chlorophyll content, and increase in harmful mutations. वायुमंडल में ओजोन की परत 3000 स्ट्रॉन्ग तरंग दैर्घ्य के नीचे वाले हानिकारक विकिरणों, जिनमें पैराबैंगनी विकिरण आते हैं, को पृथ्वी सतह पर पहुंचने से रोकती है। अतः ओजोन की कमी होने से पूरे जैव तंत्र पर हानिकारक प्रभाव हो सकते हैं। मानव द्वारा फ्रीजों, शीत भंडारों, एयर कंडीशनरों आदि में क्लोरोफ्लोरोकार्बन्स के अधिक उपयोग के कारण वायुमंडल में ओजोन की सांद्रता में कमी आई है। कुछ यौगिक जैसे कि क्लोरोफ्लोरोमीथेन जब अधिक मात्रा में एकत्रित हो जाते हैं तो यूवी किरणों के प्रभाव से उनमें क्लोरीन परमाणु मुक्त हो जाते हैं। इस प्रकार मुक्त हुई क्लोरीन का प्रत्येक परमाणु ओजोन के 1,00,000 से भी अधिक अणुओं से क्रिया करके इन्हें ऑक्सीजन के साधारण अणुओं में परिवर्तित कर देते हैं। इस प्रकार ओजोन की मात्रा में भारी कमी हो जाती है, जिसके कारण पृथ्वी सतह पर अधिक पैराबैंगनी किरणें पहुंचने से जीवों में त्वचा के कैंसर जैसे रोग हो जाते हैं। ओजोन की उच्च मात्रा भी मानव स्वास्थ्य पर हानिकारक प्रभाव डालती है। 0.2 ppm पर इसका कोई हानिकारक प्रभाव नहीं होता, लेकिन 0.3 ppm पर नाक तथा गले में उत्तेजना होती है। 1 ppm से 3 ppm पर 2 घंटे में हरारत होने लगती है तथा 9 ppm पर पल्मोनरी एडिमा हो जाता है। पैपेटी एंड गिलमोर के अनुसार 0.02 ppm पर ओजोन तंबाकू, टमाटर तथा अन्य पौधों को नष्ट कर देती है। ये गैस पौधों में वृद्धि दर को कम कर देती है। फल तथा पत्तियां परिपक्वता से पूर्व पीले होकर गिर जाते हैं तथा पत्तियों के शीर्ष जले हुए टिप बर्न्स तथा फलक लेमिना धब्बे युक्त हो जाते हैं। ओजोन रंजकों, रबड़, रेशों तथा कपास, नायलॉन, पॉलिएस्टर आदि से क्रिया करके क्षतिकारक प्रभाव डालती है। ये रबड़ को कठोर बना डालती है। अब यह सुनिश्चित हो गया है कि वायु प्रदूषण का प्रभाव पीढ़ी दर पीढ़ी तक चलता ही रहता है। The figures we can see the greenhouse effect Then comes the outdoor air pollution or smog. As we have read earlier, smog is a type of large scale outdoor pollution. It is caused by chemical reactions between pollutants derived from different sources. Smoke plus fog, they make smog. Smog is a type of large scale outdoor pollution. It is caused by chemical reactions between pollutants derived from different sources, primarily automobile exhaust and industrial emissions. Cities are often centers of these type of activities and many suffer from the effects of smog, especially during the warm months of the year.